Question 9. Which statement is correct about thermal cracking? Pressure between that is used. Don't really need to know that. Zeolite catalysts are used in thermal cracking? No. Aromatic carbons are the major products in the last catalytic cracking. The answer is CC bonds are broken. Thermal cracking. Which statement is not correct, is false. I like to just say that about ozone. It absorbs harmful ultraviolet radiation from the atmosphere, that's true. Decomposes from oxygen. Ozone. That is true. Its decomposition is catalyzed by chlorine molecules. That is not correct. And ozone holes are regions of the atmosphere with reduced concentration of ozone. That is true. Its decomposition is catalyzed by chlorine molecules. That is incorrect. So therefore that's the correct answer. What is the IUPAC name for this compound? 2,2-dimethyl 3-fluoro. Actually, we'll have to start with fluoro because it's in the alphabetical order, so it can't be either C or D. Starting with the fluoro, 3-fluoro, 2-dimethyl pentate. No, it's 2,2-dimethyl pentate. C. What's the IUPAC name of the major product formed between 2-ethyl-butene and a hydrogen bromide? 2-ethyl-butene, methane, propane, butane, butene, ethyl group on the second carbon. CH3, CH2. And we got HBr, positive. What we're going to form is something like this. Because the major product form, the Br is going to be on this carbon. So what is this? That's 2-bromo. That's obviously CH3, CH2. 2-bromo. Two ethyl butene. Going to be 3-bromo, 3-methyl pentate. I probably did that a bit wrong. Question 13, which can be used to distinguish between these two compounds? So CH3, CH2, CHO, CH3, CHO. It's obviously going to be fingerprint region. They're both the same compound. If we use tolerance region, they're going to give the same region. If we use the MR value in high resolution mass spectrometry, it's going to have very similar MR values. And if we use acidified potassium dichromate, we can get the same result. So the answer is B, fingerprint region. Excess of methane reacts with chlorine, prevents ultraviolet light. What are the main products of this reaction? Excess of methane, CH3 plus CO2. CH3 dot plus Cl2, therefore form CH3Cl plus HCl. The answer is D. Definitely won't form hydrogen, so it's either between B or C. D. Most students will probably pick. In which reaction does inorganic region act initially as an electrophile? Bromoethane with potassium hydroxide, bromoethane potassium hydroxide, chloroethane aqueous sodium hydroxide, ethane with chlorine, ethane conjugated sulfuric acid. The answer is ethene with concentrated sulfuric acid. Initially acts as electrophile. This elimination acts as a base. This acts as a nucleophile. Therefore, with alkene, it acts with the electrophile. And C, I think it just acts as a catalyst, but I don't know. It's definitely not electrophile. What's the empirical formula of hydrocarbon that contains this much of carbon by mass? So we're going to find out the moles, which is 90 divided by 12 carbon, and the moles of hydrogen. Well, if it's 90% of carbon, there must be 10% of hydrogen. That'll give me 90 divided by 12, 7.5 to 10 divided by smallest molar ratio. Get 1 to 4 over 3 times by 3, that's 3 to 4. C3H4, there we go. Which compound has the lowest relative molecular mass? Arsenic acid, carboxylic acid, methane, ethane. Fluoropropane, methane, ethane, propane, fluoro F, first carbon. Propane nitrile, propane with a nitrile group. Cn, and if you look at Cn, Cn so we've got CH3COH, CH3CH2CH2F, CH3CH2. Well, because it's propane, CH3CH2, CH of one N. So it's not going to have this CH2, CH of one N. Propylamine, CH3, CH3, CH2NH2. This is going to be propylamine, propane nitrile. Which is correct about product and use of ethanol as biofuel. Bioethanol is produced by the fermentation of glucose, present of yeast and air, purified by fractional distillation. That's true. No carbon dioxide release, that's false. Burns with cleaner flame, no. Produced by fermentation, present of yeast and air, no. What does the minimum volume of this interact with this? Well, we find out the moles. Buta-1,3-diene, 0.0200 mass over the mR. mass of MR, and I get 3.70 times by 10 to the power minus 4. To find out volume, moles concentration of volume. Volume is the moles divided by the concentration 0.0500. My answer divided by 0.0500. But we want it in centimeters cubed. There we go, that's the trick. So to convert from molybdenum cube to centimeters cube to 3. So we're going to divide my answer by 50. I should get the moles. Moles is mass over MR. And then moles is concentration of volume. Volume is the moles divided by the concentration. But we need to times that by 2. Because BR2. So times that by 2, we get times that by 2. Then, so divide by 0.05 and then we times by 1000, should get 14.8 centimeters cubed. Then we find molecules and sample gas correct. At given temperature, they all move at the same speed. At given temperature, average kinetic energy is constant. As temperature increases, more molecules and more probable energy. At temperature decreases, fewer molecules and mean energy. It's a bit tricky. At given temperature, they all move at the same speed. That's wrong. At given temperature, the average kinetic energy is constant. That's true. Temperature increases, more molecules, more probability. No. What's the enthalpy change for following reaction? Well, products minus reactants. So it's going to be minus, it's going to be, obviously that's by itself, which is 0. It's going to be 2 times by 436 minus 75. (947). Products minus reactants. Uncertainty for this is temperature change from this to this during calorimetric experiment. Uncertainties are what is percentage uncertainty. So let's calculate the difference temperature. You don't need to go into Kelvin, remember, it's a change. 2.6. That's total, change. The uncertainty of each of the readings is that. Because we've got 2 readings, it's going to be 0.1 times by 2. It's going to be 0.1 times by 2 divided by 2.6 times by 100 should get 7.7%. So the tricky part really is most students probably get, okay, that's a change, so it's going to be 0.1 divided by 2.6 times by 100 percentage, but forget, we've got 2 readings. This is the first reading, this is the second reading, or vice versa, so we need to times this by 2 to get 7.7%. Experiment is done to determine enthalpy of combustion of a fuel using a calorimeter containing water, where experiment gives the enthalpy of combustion. Enthalpy of combustion, delta H. Well, delta H is equal to Q divided by number of moles. Q is equal to mc delta T. And in this case, Q is equal to the mass of water. Yeah, M in this case is the mass of water, not alcohol. mass of water. So it's going to be the mass of water repeated. So it's going to be W times by C, which is just C, times by delta T, which is delta T. Does it look like any of these? Let's rearrange it to make C first. C. No, I just put C first. Delta T. Now delta H is Q, which is this. So delta H is going to be CW delta T, MC delta T, divided by number of moles. And number of moles is mass over mR. And what we can do is we can times by mR, so the mR becomes here and we're left with mass on the bottom. So it's going to be Q, delta H actually is going to be CW delta T, CW delta T divided by mass. And mass is W. No, it can't be. Mass is, in this case, B. Mass, yeah, because in this case the moles, for the moles, mass over mR. In this case, the mass of the alcohol. In this case, the fuel burned. So it's going to be W, and mR is going to be on the top. Okay, bit tricky one, marker. So we've got CW delta T mR divided by B. And all of these are obviously negative because, why is it negative? Entropy of combustion, no heat loss, yeah, it's going to be negative. So the answer is actually A. That was tricky, it took me quite a while to do that. Just need to memorize the equation, delta H is Q divided by moles. How do you get Q? CW delta T. But then we're divided by moles, and understanding what Q, M is the mass of water, moles, M is the mass of the fuel. And then if we divide by the moles, well then we can times by mR, so the mR comes here, and then we've got mass on the bottom, that's obviously negative, so CW delta T mR divided by B, and A is your final answer. That's the end of multiple choice questions.